Okay, humans, still working on like 3.2, let's say. And 3.2 says I can solve one variable linear equations. So what that basically means is you've got one letter and we're just straight up solving. Okay, when you see this one, you better be thinking this is a weird one. Okay, I always refer to this as the weird ones because if you look at any of our equations, like this one here, it's got letters all over the place. This one's an equation with letters all over the place. Look, there's letters all over the place, letters, letters, letters. But this one does not look like the other ones. And the dead giveaway is two equal fractions. So when you see a problem that has two fractions, so there's fraction number 1 and there's fraction number 2, there's a property that says if two fractions are equal, then when you multiply their diagonals together, then their diagonals are equal to. And we did this with the 1/2 problem, right? So if we come up with any fraction that's equal to 1/2, let's say something like 4/8, then if you multiply this diagonal and multiply the other diagonal, the result is always going to be equal. And we like equal things in math because that helps us solve equations, right? So dead giveaway is we've got this equal fractions. And now I should be thinking, okay, if I have two equal fractions, then I'm going to multiply their diagonals. It does not matter which direction we go. So you pick any one that looks simpler. So the simplest one to me looks like this diagonal on this side. And I picked that one because this has less stuff in it than this stuff. Okay? So I'm just going to multiply those two things together. So 5 times a, or a times 5, whatever direction you like, that's just 5a. And then I'm going to put the equal sign in there because every time we perform a diagonal multiplication, we know it's equal to the other side. So that one's coming from multiplying those two. And now let's multiply the other diagonal. So now I'm going to multiply 3 with the stuff up here. But you should notice that there's two objects up here. So when you multiply this diagonal, you're going to multiply this by both of the objects. Kind of like a giant distributive property. So 3 with a gives us our 3a. And 3 times 2 gives us a 6. There's lots of ways to write this problem out, but I think it's just easier if we logic our way through it and just put these together as 5a and multiply these without writing any extra steps. Just remember that you've got to take this part here and multiply by both of these objects. So anytime you have two things, you're going to have two multiplications. The first one and then the second one. 3 times a is 3a. 3 times 2 is 6. And now we're just regular old solving. So that 3a plus 6 comes from one diagonal, 5a from the other diagonal, and now we just traditionally solve. So I'm going to rewrite that without the highlighting, maybe. So we've got 5a equals 3a plus 6. The goal is to solve for a, but I can't solve for a when there's a's all over the place. So I need to bring the a's together. So I either have the option of moving this 3a over here or the 5a to this side. And I don't think I want to bring 5a over because if I bring 5a over here, then there's nothing over here. I don't ever want to leave like blank spaces. Imagine what that would look like. It would be like that. That would look really weird, right? So instead of moving the 5a, I'm going to move the 3a. And because they're on opposite sides, I have to make the 3a disappear so that it can reappear near the 5a. So I'm going to subtract 3a from both sides. I'm going to subtract that 5a. Oh, yeah, go ahead. 5a minus 3a gives me 2a. When we combine these two together, 3a minus 3a makes the a's disappear because together they produce 0. And what's left over there is 6. And now traditional problems, whatever is with a, how are they connected, and how do we undo it? So a is with 2. They're connected by multiplication, which we undo by division. So divide both sides by 2. A equals 3. And ta-da. So now if I plug that back in, I can get the same statement. So watch. If I replace the a with 3, replace the a with 3, and I get 3 over 3, equals, again, replace the a with 3. 3 plus 2 is 5. 5 on bottom. And this is worth 1. This is worth 1. See? Equal. So there you go. All right, now I got to go check out this kid's bloody nose. Peace out. Hope that helps.